So good morning, everyone. Let's see if we can get the presentation to roll properly. Welcome to this REX101 for non-aviators, why, how, and when to get started with Uspace. My name is Jonas Schärnberg. I'm a SVP and partner here at Robots Expert. As a company, some of you know us. We specialize in sustainable transportation with deep roots in aviation, and we work heavily with both regulatory and airspace aviation safety questions with use cases. Why do we need to transport goods with drones? How to do it? Also work increasingly with the cities and regions on what will urban air mobility, innovative air mobility bring. And now today we have the focus on Uspace. Many have heard about it. And now let's go a little bit and see why, how, and when to get engaged. The format today is we have 45 minutes. I'll spend 25-30 minutes going through a certain body of knowledge, and there at the end we have questions and answers, and we can have discussions and go deeper in. So during the presentation, there is a Q&A function here in Teams. You can post your question there, and we can come back to them towards the end and discuss. I write prerequisites none. I hope that I will be able to answer any question you have. We don't assume that you know very much about aviation. There might be some topics that are unfamiliar, so don't hesitate to ask about them. We are recording this seminar, and we will make it also available afterwards on the web. So let's kick into it, and let's see if the picture. Let's see. Try to make it looks strange in my screen. Tero, is it looking okay in your end, the picture? It looks blurred.
It's a bit blurry, yeah, but quite okay.
Okay, thank you. So there are two concepts you might have heard about: urban air mobility and innovative air mobility. And they're saying that, urban air mobility will bring drones into cities. But we looked at some of the facts. For instance, in Finland, there's this voluntary flight information system where drone operators can make flight notifications about when they are about to fly. The picture on the right-hand side shows the city of Helsinki, or parts of it, and we estimate there are about 30,000 drone flights done last year in Helsinki alone. The majority of these flights are done so-called VLOS, meaning visual line of sight, where the pilot has the drone in sight at any point in time. And this is done professionally for construction site, infrastructure inspections, mapping and surveying, photography, real estate agents taking aerial photographs of houses before they put them up for sale. There's also a lot of hobby use where people just fly for leisurely purposes. There's a small portion, so-called BVLOS flights, which means beyond visual line of sight. The message here really is that drones are here, and they have been here for a while. And if we look back a little bit into history, we are now on the cusp of the second revolution of drone use. In 2011, DJI introduced the first Phantom drone on the market. Before then, you needed to be a little bit of an engineer and knew accelerometers and gyros and software programming, and you needed to be skilled with the sticks if you were going to keep a drone in the air, mostly self-built. With the advent of the Phantom series, DJI tuned everything at the factory. So when you bought the drone, it flew straight out of the box, and you could focus on other things, such as using the camera it came with. And many people think today that these so-called market drones are more like cameras with a drone around rather than a drone with a camera, because they're mostly used for photography. So we had the flying camera stick was born in 2011. And these are the drones, not just DJI, but similar ones, which are used in the majority of drone applications today. Now we are facing the second revolution where we see the emergence of beyond visual line of sight flying. We will even see air taxis where you have humans on board of drones. So they're starting to fly longer distances. They can deliver goods, or you can capture data over a larger area. And also air taxis will not only start to transport passengers, but also heavier cargo. You can start to see hundreds of kilograms of cargo flying in the air. My page down doesn't work so well. So there's a recent drone strategy 2.0 published by the European Commission in December of last year. In that drone strategy paper, they divide operations into 4 categories. They talk about aerial operations, cargo business to business, cargo business to consumer, and then passenger transport. And we try to break it down a little bit here on a time scale, seeing that the majority of today's operations fall into these aerial operations. When you do it for maintenance, infrastructure, construction site, these kind of applications, or just photography. The majority of those are, as we said, visual line of sight. All of these 3 other categories, cargo delivery or passenger transport, more or less require beyond visual line of sight operations to be meaningful. So the growth of those sectors need a completely new set of capabilities, one of which is U-space, which we will see. The thing is that in aviation, ever since after the Second World War, there has been this concept of air traffic control, where you have humans in the cockpits, the pilots, they are talking to humans on the ground in air control towers. So there's a large tradition with manned aircraft, how they fly safely. And today, aviation, commercial aviation, is the safest transportation mode around. So the airspace is not empty for the drones to fly. At low altitude, we have rescue helicopters, we might have ultralight aircraft. There's a lot of activities, military operations ongoing. So when drones and air taxis eventually are now starting to operate, especially if they operate beyond visual line of sight, that means that the pilot is not seeing the drone, unlike a pilot looking out from an aircraft is seeing the airspace around them. We need a new set of information so that there will not be mid-air collisions between aircraft and drones or drones and drones. We need to share information about what the airspace is today. You would think that the airspace is kind of divided into static zones. Yes, partly, but there are also dynamic elements which can vary by the hour of the day where you can fly and where you cannot fly. Traffic information. Not all aircraft today are visible electronically. You have heard maybe about transponders, that commercial airlines have transponders that the air control tower can see them on the radar. That is true. But there's a lot of aircraft that do not have these kind of capabilities and are not visible electronically. One of the biggest blockers for a large growth in this sector is that we don't have a perfect situation picture of who is where at any point in time in an electronic way. Flight intent or flight plan means where have I planned to go? And if we just think about it, you have 2 aircraft who plan to go somewhere. If their trajectories intersect, then we need to make sure that they are not at the same place at the same time, because then that would lead to a collision. So posting ahead of time where you intend to go is also important. And then separation procedures. If we meet each other on the road, everybody turns to the right so that we know we don't have a collision. What is it in the air? So there is some common information that needs to be shared between manned aircraft and unmanned aircraft, even if both domains have their own specific information. So let's look at that. If we want to fly drones beyond visual line of sight, we need to rely on electronic means or agreed procedures. If you fly that you can see the drone, you can also see other aircraft approaching, and then you can take evasive action with the drone. So the concept of see and avoid is then fulfilled. And that's why it's kind of easy to fly drones within line of sight, because you can just, the human, the pilot, can take care of all this deconfliction and ensure there are no collisions. Now, if we don't have information about where the other aircrafts are, if we have not agreed on the procedures, then the first tool in the toolkit today is called danger or restriction areas. This is what is in use today. And on this picture, you can see an orange area here in southeast of Helsinki as an example. This orange area is used by Wing, a daughter company to Alphabet, who also owns Google. And they have already for several years in Helsinki been delivering goods to consumers with their drones, 1.5 kilogram of coffee or food or ready to eat portions have been, as a test campaign, several summers been delivered by them in a danger area. And the danger area is visible then to all aviators. So if you're a manned aircraft and you want to be flying, you see, something special is going on here. There is a danger area, and then they will look up in the instruction books. What do I do with this information? And they will find out, there are drone activities. I will fly around. Of course, it's easy to understand that if you put blockers in the airspace, it's not very efficient use of the airspace, because the drones will be at any point in time, not in the whole area. So the area as such is not, dangerous. The whole area, there is only some points in the area which are dangerous. So there might be more effective ways to do it. If you look at the picture still to the left and you look at the light blue or violet areas, these are sort of controlled airspace, which starts in this case from the ground up. And we come to the middle column. In some cases, for instance, in Sweden, there is a drone operator who is flying defibrillators in cities with air traffic control provided, so-called segregation. So within these dark blue zones called controlled airspace, every aircraft needs to get the permission to fly. They need to post their flight intent, their flight plan, and they need to get a permission from the air traffic control. That means that air traffic control can also close down a part of the control zone and say, hey, manned aircraft, you are not allowed to fly in this portion now, because there are drones flying at this point in time. So the Swedish operator is calling air traffic control. They are saying we need to fly now, and they have already pre-agreed where they are intending to fly. And air traffic control will look at their maps and say, okay, this is possible. Yes, Mr. Drone Operator or Mrs. Drone Operator, you are allowed to take off now, and you can make your flight. Let me know when you have landed. So air traffic control can then activate an area a little bit like the orange or yellow area on the left and say, now you can fly in this area and I will keep other manned aircraft out. As you can imagine, this is a bit labor intensive. It may be okay with one operation, but if you have 10, if you have 100 operations going on at any point in time, this becomes more difficult. And that's the call for U-space Airspace, where you really have, instead of humans on the ground talking to humans in the air, we have now with drones, machines in the air. They need to talk to machines and algorithms on the ground. So let's look at that in a little bit more detail. Here is a screenshot from some Uspace demonstrations and test flights that have been done over the past few years. And you can see 3 different drone flights in the same area, and a 4th one, which is planned. One flight is going in the green, going here back and forth and doing a surveillance flight of the area. Another flight is just doing a logistics delivery in a narrow corridor. And we have a wider corridor coming in with an air taxi that's going to intersect, and it's going to land at a vertiport here. And finally, we have a planned flight who is not yet active in gray, who is also going to intersect these other operations. So it's easy to see that when the complexity grows from 1 to 2 to many, we need algorithms, we need automation, we need systems to help keeping the different operations safe, and the capacity of humans will quickly end when you get these kind of operations which are in close vicinity, a low altitude, very short periods of time. Before we go deeper, let's take a step back. We talk about U-space, but you might have heard about the term called UTM, or Unmanned Aircraft System Traffic Management. UTM is kind of the technology that's used in U-space, and UTM is also in the US used to describe the concept or how it's done. In Europe, we want to do things a little bit different, and we don't want the European concept to be mixed with how FAA is doing it, the Federal Aviation Administration in the US. So the European Commission decided to call the European concept U-space, even if it relies on UTM technology. But as UTM means two different things, both the North American implementation and the technology, they decided to call it something else in Europe. If you have a discussion about this one, you will not be wrong if you use UTM and U-space as synonyms. There are some differences, but for a conversation, you can use any one. The politically correct term to use in Europe is U-space. So what is U-space and what is U-space airspace? Now, if U-space is a concept, then U-space airspace is then a specific volume of airspace which now can be established in Europe. U-space airspace is a UAS or a drone geographical zone which have vertical sides and a maximum and minimum height over ground. It can start from the ground and go to say 150 meters up, and where you can only fly drones if you have a service agreement with a U-space service provider who is providing then 4, 5, or 6 U-space services. It says in the regulation that every U-space airspace needs to have the 4 first services, and then the member state, the country where it's established, can, based on the characteristics of the environment, say that actually you also need weather information and you might also need conformance monitoring. So let's look at what are these 6 services. Network identification is a little bit like a drone transponder. It will tell the world that where is the drone, where is the operator or the pilot, and what is the identification of the drone. It's a little bit like a license plate for the drone that's transmitted to the internet, to the U-space service provider. Geo awareness is this dynamic and real-time airspace information. What are the static information about the structure of the airspace and what are today's restrictions? And this may change on a minute's notice. There might be a flight restriction area coming up for a traffic accident. The police might restrict flying over a crossroads. This can be then digitally posted and sent in real time to all drone operators in the area if it's in U-space airspace, so that they know that they can no longer fly over the traffic accident. Traffic information is exactly what the word says. It is both manned aircraft and other drones, so that this brings situation awareness to the drone pilot. And flight authorization is a difficult word for how to get the permission to do your flight. And as we will see also, you need as permission when you want to take off. Conformance monitoring just means that it's comparing the network identification, the position data with the flight authorization. If you have permission to fly a certain flight, are you staying inside of the airspace which you declared? And that's kind of a sanity check, of course. I call U-space Airspace version 1 the current one. It's the first one in Europe, the first regulation we have, and it's limited. It's not everything. It's first of all, it says in the instructions that it's intended for low-level airspace. It's also intended for areas with fairly low complexity. They don't expect a huge number of drones to be at the same time in this U-space airspace, because there will be a journey. Now, if we go from this to look at a typical flight, you plan the flight, you take the geo-awareness information, then you create your operation plan and you ask for flight authorization. You can do it the day before, maybe even the week before. This might vary from country to country. And say you got approval for 10 o'clock today, I will have this flight approved. And then you go to the site, and then just before the takeoff, you still need to ask for takeoff permission if there are any changes to the environment. But if everything is good, you take your flight, then you start your traffic information, so you get the other flights, you start your network ID, so that you're sending your position, and you might also be subject to conformance monitoring. And you end the flight, and you tell this flight authorization service that now this airspace is again free. Fairly simple. Flight authorization might also be sought just before the flight. You already go to the site, and when you are there and know exactly when you want to be flying, you then request a few minutes before your flight, you get it approved, and then you request takeoff permission and fly. But as you see, because this concerns everyone, it may slow down some operations where you just today have thrown the drone in the air and just fly. So it will bring a little bit of overhead for everyone, but the overhead will enable that all drone operations in U-space airspace are coordinated, and you know that if you have got permission to fly, the systems have checked that there is no conflict with other planned flights. This is also version 1 one-way information flow. This goes a little deep. I will just skim through this slide. But if we're thinking about manned aviation here on the top, in controlled airspace where you have air traffic controllers taking care of all manned flights, they have the authority in controlled airspace to close down parts or the whole U-space airspace for a while. It's called dynamic reconfiguration of airspace, because air traffic control is normally not allowed to send manned aircraft to fly through active U-space airspace, because as we say, it's version 1, the systems are still in their infancy, and we don't want manned and unmanned aircraft to be mixed in U-space airspace if it's inside of controlled airspace. If it's in uncontrolled airspace where air traffic services are not given and planes can fly freely, gliders, ultralight, you don't need to have a flight plan. As a manned aircraft, you can fly freely, but you need to look out so you don't collide with any other aircraft. In this case, manned aircraft will need to have some technology means, a transponder, ADS-B, for instance, and this signal is then sent and received by the U-space system, so they are electronically visible. That's the point. So in uncontrolled airspace, for instance, a rescue helicopter will have their, let's say, ADS-B out, transponder on. This is sending then their position to the U-space system. The U-space system will then tell all the drones, look, there's a helicopter coming, you need to terminate your flight or you need to take evasive maneuver. And then the helicopter will fly through. So that's how the game is starting. The end game is, of course, integration, and there are question marks on where we will go towards U-space airspace versions 2 and version 3. How can then ultimately manned and unmanned aircraft be mixed and fly freely with the common set of procedures and a common set of sharing of information? There are several steps that needs to be happened. We need to test the version 1 first, so stay tuned for that. Due to the time running, I will also skim this one before going to what's in it for us and what's in it for you as an actor. There is a package of 3 different pieces of regulation which are talking about drone operators, it's talking about these U-space service providers, and then they are talking about something called common information services, for instance, airspace information, where there is a unique set of information, only one bid for what the U-space looks like. You would not want to have the situation where there are two service providers with maybe little details are different for how the U-space is looking. That would be very, very, very dangerous. So there is a mechanism for establishing common information services, which the state is responsible for ensuring that there is a single source of truth for certain things. What is good to know is that U-space state aviation, such as military or blue light flight police, don't have to follow the rules of U-space, but they have, of course, to be careful. So they will be stakeholders in U-space. Modern aircraft clubs and also very small drones, less than 250 grams, don't have to follow the U-space rules. And there's a very special case if you fly a drone like a commercial airline. These are typically large military drones. They are also not flying according to U-space rules. So these are details that need to be looked at if you make a study on this one. So now we come to, as a city or a region or a harbor or a business or environment protection agency or a local community, what's in it for me? Now, typically with aviation, flying high over cities, 300 meters or more, this has meant that the aviation authorities are taking all the aviation discussions, and the city and region authorities take all the ground discussions and below ground discussions. If aviation is starting to fly in cities, increasingly, we are starting to see drone logistics or even air taxis. Now, of course, we need to engage with this new mode of transportation that is directly influencing the city landscape, or might fly at low levels in nature parks, something. There is a new Article 18F inside of the U-space regulation, and this is talking about the coordination mechanism. So when there is a plan to have U-space established, there will be a U-space coordinator, maybe the transport agency or civil aviation agency in the country. They will then seek input from stakeholders and ensure also social acceptance of U-space deployment, and that other noise, visual pollution, these kind of aspects are heard and understood. And only after that one will there be a U-space designation. Maybe the area will be changed. Maybe there are U-space restrictions. You cannot fly at night, for instance, unless there's an emergency. And what are the U-space services? And even when the plan is done and you execute then the U-space airspace and establish it, if there are exceptional cases, you can also, the coordination mechanism can influence that the flight operations are stopped until we can clarify what caused this or that. And there will be a review process regularly to maintain, restrict, and reshape based on feedback. So it becomes a part of a dialogue, not just the aviation authorities, but also the broader community to, as they say, ensure the alignment of innovative aerial services with the needs and preferences of their citizens. So this is why it's important to stay tuned and to get to a call for action. And before we go to the questions and answers, if you are new to U-space and new to U-space airspace, the first thing is to learn enough that you can have a discussion about this one, that you know a little bit about what's in it. What is driving it? What does this innovative air mobility mean? What does U-space mean? Then if you are a city or a region, to create a vision, not the U-space, but what is it used for? We are sometimes joking that in the early days of drones, everybody loved to look at, carbon fiber with gleaming surfaces, and it looks, media sexy and all of these things. But at the end of the day, when you go past that one, nobody's really interested in the flying, but everybody's interested in the capacity it brings, and not just the capacity, but also what does it mean for life cycle analysis, CO2 emissions? Are we replacing reducing emissions? Are we keeping them standard? Is it even increasing emissions? These are important questions to understand. But start with the demand. Why are we using it for? What are we transporting and why? What does it cost? When can we fly? But also the demand is difficult sometimes in this early industry cycle to find. So supply creates demand. And if you want to be forward leaning as a region, then by investing early on in getting these kind of capabilities, drone operations set up beyond visual line of sight, maybe establish a U-space airspace to facilitate it, you will find that supply will create demand. And then you can learn about it and what does it mean for in your setting. And also important that this is a European regulation that is then tied into the national aviation laws. But there are other regulations such as environmental permits, maybe city permits to take off and land use, these kind of elements that are important to link locally to what does it mean versus the aviation domain. And create a vision for, what do we want to do? Do we want to wait and see, or do we want to lead the pack? This should ideally link into sustainable urban mobility plans. It's not just about drones, it's about electrical aviation, electrical ground transportation, maybe the hydrogen economy. It's all part of this industry renewal that's happening when we're trying to make plans to reduce the impact on the planet quickly. But it's people behind the business. So it's important to link the different domains, even if you're talking about maybe urban and regional domains to aviation domains. Even in aviation, there are silos, and you have manned aviation are really scared about drones sometimes, for instance, helicopter operators. So the more we can have dialogue between the different actors, the quicker we will be able to focus on the things that matter. And also the citizens matter, of course, so that we are not focusing on maybe beer or pizza delivery, but we are thinking of what is the real benefit to society. And we think, as robot expert, that one of the early use cases will relate to healthcare, where we can, give better service to the community. And expect crawl, walk, run. Aviation is conservative because we want to keep it safe. So finally, on the timeline, regulation is now in force since the January 26th. We will, during maybe this year, but for sure next year, see early U-space airspace deployments and early operations. But the operational ramp up of U-space airspace will, in some countries, start in 25. In some countries, it will take to 26. So it is crawl, walk, run. But now is the time to get engaged. So with that, opening for questions and answers here, I will open it here. I don't see any questions now, but if you have any questions, we're happy to take them. Put it in there in the Q&A or the chat, or rather the Q&A would be the best one, and then we can address it. While you're thinking about that one, some of the experiences we see here from Europe is that transportation hubs, nodes, such as we have on the left Antwerp port. To have a port creates logistical challenges and in and out of the harbor, but also it's a very complex operation in the harbor, and an eye in the sky will bring tremendous operational benefits to monitor traffic movements, to monitor that there are no oil spillage in the harbor, and if it is, to be able to qualify it quickly, etc., etc., etc. We see that, Hamburg has a similar situation where you have traffic congestion about the harbor. These are like demand generating nodes and helps focus some discussions and keep them output driven. Yes, so we have a question, ADS-B and ADS-L. Thank you, Lasse, for a question. ADS-B is like a transponder on aircraft. It's kind of new technology. It doesn't need a radar to work, and it sends once a second the position of the aircraft to anybody who is able to listen on the frequency. So it's like a digital signal beacon. And ADSL is a variant of that one that's just now coming, and it's intended for drone usage. And also it's building on technologies. If you ever heard about FLARM, which is popular with glider aircraft. So it's a lighter version, more affordable version, but it's not certified, but it's the same functionality that's sending the position of the aircraft. And Vadim is asking about the U-space coordinator. It's typically an agency, such as in Finland, it's probably going to be Traficom, the Civil Aviation Authority, that is tasked by the Ministry of Transportation to take care of this U-space coordination, but it can be another entity also. Timo is asking how to get U-space to Helsinki. It's a good question, and I'll ask a little bit broader. U-space is established for a need, and it can be a business need. It can be also other needs, nature preservation. Maybe a natural park wants to control how drone operations are happening over the national park. They don't want to stop it. No, absolutely not. But they don't want people to just fly. They want to have some kind of coordination. Or a business might want to establish drone logistics between different points, say a hospital and a laboratory. Maybe a U-space airspace around that one could be good, but it needs somebody to pay for it. And ultimately, the user will need to pay for U-space services. So we often say that aviation and aircraft don't fly according to the laws of physics, but according to the laws of money. And here is the same thing. So how to get U-space to Helsinki? Put the money on the table. Lauri is asking, who would be responsible for setting up a U-space for a certain location? City, Traficom, somebody else? So for sure, the aviation authority would be the authority who formally establishes it. And the U-space coordinator, they might be the U-space coordinator, and if so, they have an obligation to ensure that different stakeholders are then invited for a discussion before it is established. And there will also be risk assessments made before you can establish them. Marco is using as a business-wise, what is the best business case so far, and what are those low-hanging fruits in the near future that we could use to describe possibilities and opportunities in this field? We see a lot of healthcare applications. It can be everything from blood and transfusion medicine. It's increasingly specialized. There's not just A, B, and zero blood. As you learned maybe in school, there are hundreds of different kinds of blood, and they need to be made fresh, and then you need to be quickly transported on demand to the patient. And we see a large centralization in healthcare, where laboratories and these blood transfusion services are not necessarily at the hospitals. Some medicines also need to be mixed and used within the hour, or you can have blood samples which needs to be brought to a laboratory and analyzed, and then within maybe 10-15 minutes the patient and the doctor can get the results. This has been, for instance, piloted in Zurich, where they've flown 20,000 flights like this one, and the staff just goes out and put the box into the drone hub, and it's automatically taken forward. These kind of business-to-business applications, when you have between two prepared sites or several prepared sites, is where we think the game for drone logistics will start. But some are also piloting one-to-many, where you have B2C drone logistics. But it could be spare parts also from central warehouses. So these are the low-hanging fruits that we think are there. Christina, thank you for excellent presentation explaining the time frame, especially important for the cities and municipalities with densely built areas to get prepared for this systemic change affecting multiple sectors. Effective coordination is definitely needed. Thank you, Christina. I couldn't agree more. We always say it's people behind the business, and the technology needs to serve us, the people. Vadim, as a note, some European experts insist that U-space is the correct term to be used in Europe. It's a broader concept that includes the notion of UTM, but also includes infrastructure and procedural considerations. You are correct, Vadim. U-space is a broader concept than UTM, but this is also an entry course. And if somebody talks about UTM, you can think about U-space. You're not wrong, but there are nuance differences. And Christina is asking, as per the spatial planners, we have had discussions how the balloon in the U-space illustration to be understood. Do they carry transponders? Increasingly, balloons do carry some kind of transponders. FLARM, I've seen FLARM being carried, but not every aircraft does. There are ultralight aircraft, other aircraft which do not. So it's a mixed bag in the airspace, and ultimately, we think at Robots Expert that we need to go towards an aviation internet of things where all aircraft are nodes in a network, when you know the position in real time. You can be private, but you cannot be anonymous. You need to know, and then military and other actors are special cases, of course. But even then, they need to keep track of where they are. So that there are different wireless connections to the air. It's a challenge. Mobile network are being discussed, but there are a few years down the lines. We talk about this ADSL, ADS-B beacons. They are part of the solution. It's not a one size fits all, one thing that will do ring that will rule them all. We will need to see convergence of different technologies to get this working. Thank you for joining this webinar for 101 for Robots Expert. I hope it was useful. We will trim this recording and make it available also for future use on our website. Thanks everyone for coming, and have a great day. Thank you.